All right, now we are going to talk about a frequent item set generation. So basically, here, if I'm given some threshold for support, right? So some S min, I'm going to look for all item sets whose support is bigger than or equal than this threshold, right? And the first thing to do here is to introduce the so-called a priori principle. Well, now, if we were to look at all possible item sets, then there would be just too many of them to go through, right? So that there should be some kind of a method to rule out some item sets that we shouldn't even bother considering and counting the support of. Now, so all possible item sets can be visualized as this so-called lattice, right? So here in every next level is going to contain item sets with more items, right? So here on the level 0, I have item sets with 0 items, which is just the empty set. So here I have item sets with 1 item. So here 2 item sets, 3 item sets, 4 item sets, and there is just 5 item set. And there are arrows from a level to the next level whenever the item set in the level above is a subset of the item set in the level below, right? Like if you say look at, I don't know, at A, right? So A is a subset in A, B, A, C, A, D, and A, E. So that there are arrows here, but there is no arrow from A to BC because A is not a subset in BC. Okay, now theorem. So if an item set is frequent, then all its subsets are also frequent, right? So let me prove this theorem. So what does it mean? So frequent means that we have some minimum support level, so S min, right? And if we have an item set and we know that it is frequent, so it means that its support is greater than or equal than S min, right? So then we need to show that all its subsets are also frequent, right? So suppose that X prime is a subset in X. Okay, so what is the support of X prime, right? So the support of X prime is going to be the support count of X prime is the number of item sets containing X prime divided by n. Okay, but now just think about it. So since X is smaller, X prime is smaller than X, right? So imagine that, I don't know, X is beer, diapers, and milk, and X prime is just beer and diapers. So then every item set that contains X is also going to contain X prime, but probably some item sets that contain X prime, they do not contain X, right? So which means that the number of items that only contain X prime should be bigger than the number of items that contain X, probably equal. So it's going to be bigger than or equal than the number of items, the number of item sets that contain X over n. And this is, we know that this is bigger than S min. Okay, so the theorem is proved. Very, very, very simple theorem and extremely powerful, right? So we can also say that the support is a decreasing function. So which means that if an item set is not frequent, then all sets, all other item sets containing it are not going to be frequent either. And this observation allows us to just reduce the search of frequent rules. And this strategy is known as support-based pruning. So let me explain what it means, right? So suppose that we have some we have chosen some threshold for the minimum support, right? And we are looking for all item sets whose support is bigger than or equal than S min, right? And suppose that we have looked at one item sets, right? So there are 5 of them: A, B, C, D, and E. And let's say that the support of just C is not is smaller than S mean, and the support of E is smaller than S mean. So it means that the support of anything that contains C is definitely going to be smaller than S mean. So we shouldn't even bother counting it, right? So AC, so everything that contains C, BC, CD, CE, we shouldn't even bother considering, and everything that contains E, we shouldn't even bother considering. But then everything that contains these 2 item sets, AC, AE, BC, everything below, we shouldn't bother considering. So everything for which we have arrows from all these item sets that we ruled out, we don't even bother considering. So AC, ACD, ACE, AE, so BE, BDE, CD, CD. Okay. And it kind of reduces the search quite substantially, right? So, which means that, out of, actually, at this stage, most of what we have here, we just rule out. Same thing here, right? So we should rule out ABD, right? Because it contains B and E, A, B, C, E, we should rule out, and we should, so everything at this stage, we just rule out. So the possible candidates for trying, for checking are just ABD and AD, well, actually not even ADE because it contains DE. Okay. Now, so if we rule out just 2 out of 5 individual items, then it greatly reduces our search for 2 item sets, 3 item sets, 4 item sets, and so on. All right. Maybe I'm going to be a little bit more specific. Okay. So if, say, we are looking at the item set beer and diapers, right? So beer and diapers. And so the support count of beer and diapers, so we just look at all item sets that contain beer and diapers together, and there are 3 of them, right? So the support count is 3. So which means that if now we the support count is bigger than or equal than the minimum support count, right? So which means that if we are looking through all possible item sets, at some point we are looking at beer and diapers, the support count is above or equal than the given threshold. So we should continue looking, right? So then in future, it means that we cannot rule out anything that contains beer and diapers. So if, say, in future we want to consider beer, diapers, and something else, say bread, then we will have to do it. So we don't, at this moment, we don't know. So the support count of beer and diapers and bread could be still 3 or could be smaller than 3. We don't know, right? But if, say, we at some point we consider the item set beer and bread, right? And beer and bread. So if we look at transactions that contain beer and bread together, there are just 2 of them. So the support count is 2, which means that anything that contains beer and bread, we shouldn't even bother considering, right? So if, say, for example, beer, bread, and diapers, beer, diapers, and bread, at this moment, we can rule out. We shouldn't. So once we have looked at beer and bread and we have figured out that its support count is below the given threshold, we shouldn't even bother looking at beer, diapers, and bread at all in future. Okay, now please do the quiz.